So, hello everyone, and welcome to this weekly session that we conduct, Ask AuxEn Anything. And this is an online platform for civil structural engineers to interact with us and ask their doubts or queries related to any project that they are doing, or RCC steel design concept, or construction and site issues. So, this is the 49th such session that we are conducting, and let us begin today's session by taking the queries that have been put. So first we will take the queries from the Google form, and then we will take the queries from the live audience. So uh, the first query that has been asked is by engineer Nihal from Kerala. He is a working professional and he is asking these questions. So I am using a front to front channel section for column using batten plates. Can I provide moment connection on both axes of the column? So he's saying he is having this type of a channel section plan. I hope this is visible to everyone. And then he's providing batten plates over here. Now he's asking, can he have moment connections on about both the axes? So let's say in the plan view, if this is his beam, okay, and connecting on this face, and this is his another beam connecting on this face. He is asking, is it possible to have moment connections about both the axes? So for this purple beam, you may be able to develop. I hope when you are asking moment connection, you mean rigid connection you are asking about. Moment connection, some moment partial rigid connections or partial moment connections you can always develop. But I assuming when you are asking this question, you are meaning with a rigid connection. All right. So yeah, so I am answering this question with the view of rigid connection and not moment connection right now. So about for this purple beam, you may be able to develop a rigid connection over here, and in one of the courses we have done this kind of an arrangement. But for this axis, for this green colored beam, it is very difficult to have a moment connection when it is on this batten plate, because these batten plates undergo deformations, deflections, so it becomes difficult over here. So this axis it is difficult. About this axis it can be created, though again it's not a very good way of doing it, but still I would say it can be done. But about the other axis it is difficult. Okay, so if this is your assembly, I would suggest you to not go for moment connections and to go for some other connection strategy. His second question is, what types of moment connection is possible in this type of scenario? See, you can come up with bolted, welded, anything, but as I just said, for this axis it is easier to have it, but about this axis it is more difficult. So my suggestion to you would be to not bother about trying to create a moment connection and instead look for some other strategy over here. Okay, then his next question is it possible to use an angle section on flanges of the beam? Is it possible to use angle section on flanges of the beam? I'm not sure about this question, what he's asking. Is it possible to use angle sections? Where? With what regard you are wanting to use angle sections? So are you talking about cleats? So I think he's saying, if in continuation to this question he's putting this next doubt, I guess what he's saying is that on this face he has this purple colored beam connected. These are the flanges, and then he wants to put cleat angles like this, I guess. Yeah, so this is a regular, see, this type of a connection is a regular assembly providing cleats. So yes, of course you can do this. Cleat connections or putting cleats over here, putting a web cleat, putting flange cleats. This is obviously done and it is the more prevalent option on site. So you will not see a lot of extended end plate connections being provided. Actually, you see this kind of a connection more uh, on sites. So this gives you a decent level of moment rotation behavior, and it tends more towards the, I would say, a rigid connection. So this type of an arrangement is possible. Maybe you could add some stiffeners over here for better performance. So that means you could add some stiffeners just so that this cleat angle does not undergo bending. Okay. So this was engineer Nihal, and then he has put another query. So let me take that as well. He is asking, I am designing a steel pedestrian cantilever bridge. You need to provide sketches for better understanding. Uh, Reading the text may not be always be very helpful. So there is no sketch that you have provided, but still let me read. I am designing a steel pedestrian cantilever bridge. I'll just check on email if he has put any query. Sorry, any on email if he has put anything. Let me just see once on the email. Maybe he might have put some images through email. So I'll just see that. Mr. Nihal. No, he has not put any image. Any supporting image has not been put. So that's okay. I'll just read from what he has written. I am designing a steel pedestrian cantilever bridge with cable stays from tower. When assigning tension only specification in cable, the analysis shows error. When assigning cable specification, the analysis result shows compression in some load cases. So that might be the reason. If compression is there in your load case, compression in load case might be a problem because cables cannot take compression. Cables can only take tension. So there might be a problem over there. What is to be done to solve this? Any other method to do cable analysis? So I myself have not I have not done myself any cable analysis till now. So I may not be able to provide any input when it comes to the uh, syntax to be used in STAD. So I don't have much idea about it because I have not done cable analysis. But configuration wise, let's say if you're for some of the load cases, your cable or your structure is showing tension, sorry, compression, maybe you have to add cables. For example, I'm not sure about your bridge, but let's say this is some kind of this assembly. This magenta colored is your pylons, let's say, and these greens are cables. Okay, this black is your bridge deck, and person is going to walk like this. Wherever these cables are attached, they might be attached to the lower cord or top cord. Right now I have just assigned them at the top cord. And for some of the load case, let's say for this direction of a wind, your cable will undergo compression, so then it's a problem. So in such cases you may think of adding some cables so that they generate some kind of tension when you're wind forces or any other load case creates compression in the green cable. So your green cables are your main cables, but for some directions of wind, it's a possibility that these green cables come under compression, and maybe because of that, STAT is showing some error. So you might think about adding cables as shown in the orange color, or you may also think of adding sway cables. So how sway cables will look like? So if I show you the plan view now, here I was trying to show you an elevational view. So let's say this is the plan view, this is your pylon, and maybe this is your bridge deck in plan. I don't know the geometry, I'm just assuming something. And then maybe if you cannot add cables shown in orange like this, maybe you can add some sway cables in plan view, something like this. Okay. Again, I'm not sure about your geometry, just a suggestion. So that might be one of the reasons why, uh, or that might be the way to avoid compression in your green colored cables, which are the main cable stays right now. And maybe because of the compression in cables, your STAD is showing error. So these are my suggestions. I have not done cable analysis myself in STAD, so I'm not quite aware of the appropriate syntax that have to be used. But configuration wise, these were few of the suggestions that I had to give you. The next question is from engineer Rohit Kashyap. He is from Guwahati and he is a working professional. He is asking about the rigid zone factor in ETABs, and I think uh, this comes in the assign frame end length offset window. So if I just show you a screenshot, uh, this is where the rigid zone factor comes. So if we do automatic from connectivity, what happens is that if you have modeled your column like this, elevational view, okay, and if you have modeled your beam, generally we do the center line modeling. So your beam is modeled from center like this. Now if I do automatic from connectivity, then it takes the beam moment diagram, it will give from the face, and for the column it will give from beam top or bottom. If you select this option defined lengths and put 0 0, then ETABS will start taking the center to center dimensions. But this rigid zone factor I have not used myself, so I'm not sure, and it never came to me. I mean, I never thought about this, what this stands for. So anyone in the live audience who knows about this rigid zone factor? Hello? Anyone in the live audience who knows about this rigid zone factor, please? I personally have not used, I think, this option any time before. I just use this automatic from connectivity option or the define length option. So if you put automatic from connectivity and this is your beam and this is your column, it will take the beam span from the face and the column length from beam top and beam bottom. If you select define lengths and put 0 0, it starts taking center to center dimensions. Accordingly, the effective lengths and moment diagram is also slightly altered. But about this rigid zone factor, I'm not sure. I've never used this option before. Anyone who knows, please? Okay, I'll try to explore this more. Anyone in the live audience who knows about this? Nobody knows? Okay, I'll try to find it myself, maybe by reading the documentation. Or you can also experiment. See, Mr. Rohit, you can just try to experiment, make a small portal. Doing experimentation is the best way to learn. So just apply some load, see what is the moment diagram you're getting, whatever, and then try to alter these values and see what's happening. So this is the way I will also try to. Uh, this is the way I will also try to understand what is happening with this rigid zone factor, because I have never used this option before. So you can also try this out. And if anyone in the live audience knows more about it, please inform. Uh, please inform us. Okay, so nobody in the live audience knows about it, so I'll just move ahead and maybe I'll also try to see more about this later on. Next question is from engineer Raghu K. He is a working professional from Bengaluru, and what he's asking is this: IS is table 1 of IS 1893 2016 related to piles. Can we increase the pile capacity as per this table? Yeah, you can. You can. Actually, that table does mention piles also, if I remember. Let me just open that table. If I remember correctly, that table does mention about piles. Let me just see. Table 1 of IS 1893. Yeah, it does mention skin friction. Percentage increase in net bearing pressure and skin friction of soil. So in piles, we are relying on the skin friction. So that means you are allowed to, and it's written also in the table. So I don't know if we will be able to see over here, but this table does mention about the piles also. So this is that screenshot, and here it is mentioning, although this might not be very visible, but here it mentions for piles weighted. Okay, so here they are trying to say how to find out the end value for these types of uh, substructure. But yeah, because the table clearly says percentage increase in net bearing pressure and skin friction. So in piles, if your piles are friction piles, we do rely on skin friction. If your piles are end bearing piles, we are relying on bearing. So overall, because this code, sorry, because this table allows us to increase both skin friction as well as bearing. In case of piles also, you can increase, and we do increase in all our designs. We do increase the pile capacity by these percentages as shown in case of seismic load combination. So if your strata is rocky or hard soil, so assuming let's say that you are going for an end bearing pile, okay, and then you can increase up to 50%. If your case is of a medium or stiff soil, definitions are given over here, then you can increase up to 25%. For soft soils, no increase allowed. So yeah, short answer, for piles you can take this advantage. His second question is, okay, so he has put an image, supporting image over here in the email. So I'll just, no, he has put, this is a different image that he has put. His question seems to be something different. Half of the footing extends over this existing drain due to space constraint. Okay, I'll just put this image. This is the image he has shared. He's writing half of the footing extends over the existing drain. Now, where is the drain? I'm not sure. Half of the footing extends over this drain, over the existing drain due to space constraints. How can this situation be addressed? I'm not sure about the situation and the issue over here. So maybe you need to add more sketches. But then he has put another question on the email. Mr. Raghu is informing second and third questions are different. Okay. Okay, so this question that you have put, okay. So this image is not for this question. This half of the footing question is different. Is this image related to half of the footing question, or this image is? Yes. No. Arre? What is this? Yes. No. Okay, I'll assume. Let's not be confused with the image. Let us see what the question is. He is saying half of the footing extends over the existing drain. So I am assuming there is a in plan view there is this drain that is there, and then there is this column, and then a footing has been provided for this column. This is the plan view, and when the sizes of for this footing are calculated, what Mr. Raghu is finding that half of the footing is going like this. So his question is how can this situation be addressed? So in sectional view, see in sectional view, for footings, first of all you need to understand that whatever area is required, that has to be satisfied. Plan area has to be satisfied first for bearing. So so plan area has to be satisfied for bearing. So if this is the drain, and there is no alternative for that, so if this is the drain and this is my column very near, and then you had a footing which was getting obstructed over here, one of the ways is to underpin. That means to take your column below this drain and try to put this. So for this you may have to do the excavation. You may have to do the excavations and temporarily support the drain also. If that is not possible, then you may have to dismantle the drain in this portion. So in this portion, just dismantle this drain and cast the footing and then put the drain again. This can be another option. Or you may have to shift the column. That can be the third option. But what I'm trying to explain is if you need the bearing area, so this much area, if it is required, it is required. Okay. So there is no alternate for that. You may think of this that if your area is getting obstructed over here, to compensate, maybe you can provide a footing like this, which has similar areas. Now this may become eccentric with respect to this column. So then you may have to, let's say, do some tying up of this eccentric footing with a nearby column if that is possible. So I just tie this up. That might be another option. So two things, area has to be compensated. So you need to have this much area provided. There is no alternate for that. Now that area, either you dismantle this portion of drain and provide that area as concentric, as concentric. Otherwise, you make this purple type of area. So this might become an eccentric situation. Then try to tie this eccentric foundation with a nearby column. So these types of options you may have to think about. Then Mr. Raghu is asking detailing of the raft level difference shown in the figure. Could you please? Acha, this image was for this question. Very good. So his next question is related to this image, and he is saying, let me just. So his I think he is having this raft. It is at this level, and then there is this raft at this level. So he's asking, could you please explain how to detail the junctions? So I think this is his raft at this level, and then he has another raft. I'll just try to draw the rafts, okay? So one raft is at this level. Wait a minute. And then there is this raft at this level, and this is the raft thickness over here. This is the raft thickness over here. Now he's asking how to do the detailing at this junction. So generally, we try to do this way, that you try to create a 45-degree angle over here, okay? And wait a minute. First of all, ensure that at this junction, let's say this was your junction, okay? This was the line. Now you first of all ensure, make an offset which is equal to raft thickness over here. So make an offset from this line like this. Make an offset from this line. Make an offset from this line over here, and then try to make a 45-degree angle. So what I'm trying to say, that after this junction I'm getting same thicknesses, at least you will get more, but at least you are getting that much. So you try to detail it like this, that this raft, something like this. Why we are giving a 45-degree angle? For proper better load dispersion, and this was the point of junction. So this can be one of the ways. So your raft is now looking like this, okay? So this can be a detailing option, or else you could obviously do it like this, that this line and then this line, and then this is the thickness. So you make a thick vertical element over here, which is like this. So this is your second option. So this is a thick vertical element that has been provided. This was the junction line. But with a view of load dispersion, this 45-degree angle thing is better. So I am saying this, provide this 45 and then do it like this. So this is a better situation to have. And reinforcement wise, you may have to, if see, because of this level difference, your top reinforcement you will not be able to develop. So you may try to, in the software analysis, you try to create a, edge release over here at this level difference point. So in the software, what you do is, wherever you are having this uh, rafts at two different levels, in the software you try to have a edge release created, because you are not sure about this reinforcement, how much you will be able to properly develop it. Although in our detailing, we will do it this way, that I'll take it till LD, let's say this top bar I'll try to take, but practically it might be difficult. So better to have a edge release introduced on this line. Clear? So you can do something like this. This was his query. So these were the questions that were asked on the Google form. Now we take up the queries from the live audience. So the first query is from Sumit Shah. He is asking, can you please explain load path in different types of bracing for lateral loads in steel structure? Load path. So load path. The one of the bracings is this type, X bracing, let's say. So in X bracing, the generally we will assume that the lateral loads are taken by the bracing in tension. So if this is the direction of lateral load, then these bracings are in tension, so they will take the lateral loads, and for the reverse direction the other two bracings will be activated. So bracings in tension are assumed to take the lateral loads. Now if I were to introduce a bracing or concentric bracings, so we have another bracing system like this. In this also generally we assume that the bracing in tension takes the loads. But if I were to talk with respect to ductile detailing, let's say, okay, I'll talk with respect to ductile detailing. So in ductile design detailing of steel structures, suppose you were to provide these bracings. So in this type of a system, which is called as concentrically braced frame systems, or this is also a concentrically braced frame system, we assume that these bracings in tension and compression will uh, will take the lateral loads. Okay, in tension they will take the lateral loads up to level of yielding. In compression they will take the lateral loads up to level of buckling. If I have this kind of a assembly, there's another option possible which is called as the eccentrically braced frame systems. So in this we assume that this element, this yields and helps to take the lateral loads. Okay, so this is called as the link element. So in case of eccentrically braced frame systems, we assume the links to yield and take care of the lateral load. So this is the other option that we assume. But in general, if you are not talking about the uh, ductile design detailing approach, then generally the bracings, how we assume is that bracings will take the loads in tension, and that's how the lateral load is resisted. Okay. All right. So next question is from engineer Ajinkya. So he's saying, can you please share your Mr. Ajinkya is asking, can you please explain, please share your opinion on why latest 1893 does not talk about 18168? Is it going to be replaced by upcoming 13920? Should we continue studying 18168 course, or will it be obsolete soon? See, I have not gone through IS 1893 right now, but what I have learned from people is that the IS 18168 will be refurbished, or will be put as an IS 13920, some part of it. Okay. So maybe they will bring a part 2 or a part 3 or a part 4, whatever they bring, but they will put this 18168 into, rename it as 13920 some part. So then you will have a IS 13920 part 1, which will cover the RCC structures, ductile design detailing of RCC buildings, and then they will bring another part of 13920. I'm not sure if they bring it as part 1B or whatever, or part 2, part 3, whatever, and that will be for steel structures. You got my point? So it will just be a renaming of 18168. Now, because this 18168, if you read into it, I think you have already taken that course on 18168. If you read that code and if you compare, it is almost the same as AISC 341. So it's a direct lift off from there. Okay. And that already is quite up to date. The AISC 341. Actually, that also got revised in the year 22, but uh, not many differences between the 16 and 22, except for some section classification values and all those things. So what I'm trying to tell you that this 18168 is already quite updated. Okay, so they will not make it obsolete. They will just do a renaming. So your 18168 will be renamed into 13920 sub part, so that logically it becomes easier for the engineers, that 1893 is for EQ load calculation and 13920 is for ductile design detailing for EQ effects. So 18168 will not be obsolete. It will just be renamed into another code number. The clauses, I don't expect them to change, because as I just said, 18168 is quite up to date in itself, having been taken directly from AISC 341. So I don't expect any changes rather other than the renaming. So don't worry, you continue studying the course. Nothing is going to change. The names will be changed. That's it. That's what I'm expecting. Then Shashi Kumari is asking, can you please explain weak beam strong column concept? So this comes from our capacity design approach. This concept comes from the capacity capacity design approach, where we say that we will like to have, or we will like to initiate failures in the zones which do not lead to vertical collapse or any brittle failure. All right, and for that, we might strengthen those actions where the failure is undesirable, so that the failure can initiate at desired or favorable locations. So that is what is capacity design approach. And in that, let's say this is the elevation, these are my columns, this is my beam. So I do not want a failure in column to occur, because a failure in column can lead to a global collapse, vertical collapse. So I might rather like to have, if at all a failure was to happen, because I want failures to dissipate the earthquake energy. So let's say if I want failure to happen, it should happen in the flexural action of the beam. Okay. In shear, if you remember, anyway, we are strengthening the shear action by, sorry, we are designing against any shear failure, brittle failure, by providing confinement reinforcement, closely spaced rings, by designing this beam for capacity shear and all those things we are doing. So now, to avoid the failure in my columns, I am deliberately increasing the capacity of moment capacity of columns with respect to beams. So that means if at all a failure has to happen, let it happen in the beam in flexure rather than happening in the columns. So therefore, what I do is that I design and proportion my column in such a way that the moment carrying capacity of beams connecting at a joint in a particular direction. So if I were to sum up the moment carrying capacity of these beams, and let's say column above and column below, so I want that the moment carrying capacity of columns should be 1.4 times as strong as the moment carrying capacity of beams. Okay. So this is called as the strong column weak beam concept, whereby we are deliberately proportioning our columns in such a way that the moment carrying capacity of columns is 1.4 times as high as that of beams. This 1.4 factor is as per the 13920 requirement. If you look at other codes, these factors are different. The Indian code uh, has taken this value. So so this is what is meant by the strong column weak beam concept. And in our courses on seismic codes, we have explained these calculations also, and the ETABS and STAT softwares also do it quite well. So yeah, this is the strong column weak beam concept that we use in ductile design detailing. Mr. Ajinkya is asking, please explain briefly design and construction sequence of diaphragm wall. I have never done diaphragm walls myself, so I mean, I understand the logic and I understand the principle, but I have never done myself, so I'm not sure about the books which cover, or uh, I mean, Yeah, I mean, I don't have any information right now. Maybe any book which is on substructure, any good book on substructure would cover the design and construction sequence for diaphragm walls. So you may be interested in going through those books. Mr. Magaj is asking, what could be the design approach if long retaining walls attached with 5 basement slabs, but at some particular location there is either staircase or ramp? How to design this staircase or ramp area? Very good. So what he's trying to say is, I'm assuming what he's asking by looking at his question is, in plan view, let's say this is the retaining wall in plan view, and this is also acting as a basement wall, and then there is a ramp or staircase because of which there is a cutout over here. Okay, and if I were to draw the section, what is happening that this is a basement wall, and one, this is the raft, one, two, three. Is this what you are asking? Four, maybe five, whatever. So because of that cutout, or because of this ramp, and because of this staircase, he's saying that this is sort of becoming a freestanding basement. And of course, at fifth level, let's say he's getting a tie. So this is becoming a freestanding portion of the wall at these locations, because there was a staircase, and that staircase meant that, or ramp or whatever, this meant that there could not be any connectivity that could be introduced. Is that what you are asking? Hello? I guess so, yeah. Yes. Very nice. So see, 5 floors is a lot. First of all, you try to have a system where you are getting at least a tie after 2 3 levels. So you talk with your architect and tell them this difficulty, that over 5 levels not getting a tie is a lot. See, of course, you can introduce some ties. If you are having ramps, your ramps, let's say, are circulating like this. Okay, so you can get ties at mid landing level at least. I don't have your architectural plan in front of myself, but this is just from, I mean, assuming that your ramp is, let's say, in this direction circulation, maybe at mid landing levels, you can always introduce ties. So at least one tie you get over here at one level, mid landing level, one tie you get over here. Okay. So that is one possibility. Let's assume that for 5 levels you're not getting a tie, then it's a problem. Then you may have to introduce counterforts. So try introducing counterforts over here. Okay, so then those counterforts will have to support your 5 levels, and then whatever is the lateral pressure acting from outside, those counterforts will provide resistance against it. uh, Mr. Magaj is saying, can't we take staircase slab or ramp slab as diaphragm? Yes, you can take, but then it has to connect on this side also. See, if this staircase ramp is connecting, and assuming it is connecting on this side also, then there is no problem. Then this staircase ramp itself will provide the lateral tie that is needed. You understand? So if that is the scenario, then there is no problem at all. Assuming that this part of the staircase then connects to this portion of the structure also for continuity of lateral loads. So if that is the scenario, if there is some column over here and that staircase slab is connecting the two portions like this, then there is no problem. Then you need not be worried. But if that is not happening, if your staircase connectivity is such that it's not getting connected over here, maybe, then you have to be slightly worried. And then in those cases, you may have to introduce these types of counterforts uh, to strengthen your wall. Or then you may have to introduce some ties. You need to sit and talk with your architect about it. But if there is a staircase slab that is connecting both these portions, then I don't think there is any difference, any problem. All right. Then his next question is, can we take the passive pressure resistance to counteract the moment due to eccentric footing? You can, but that passive pressure is acting on such a small area that numerically it will not offer you much. Numerically, that passive pressure that will be that acts is acting on such a small area that it's not going to offer you any significant uh, counteracting movement. Okay. Yeah. Mr. Rohit Kashyap is asking, will you be doing a course on new EQ codes? Yes, we will do it maybe in the coming months. I'm also waiting for the softwares to incorporate these changes. So I am hoping that these softwares also, uh, what should I say? These softwares also update and they also include the new code. So I was just waiting for that. That maybe in the coming 2 3 months, when your softwares include this, then it will be better to do this course. Mr. Magaji is asking, in South Side, consultants use transfer slab systems. How much it is good in lateral behavior? I don't know because I have never used transfer slab systems myself much. But again, the lateral behavior, because those columns will terminate on the transfer slab, so you have to have some columns or some lateral load resisting elements which continue right till the ground for proper lateral load resistance, because the columns that get terminated at the transfer slab level, they will not offer you they will not offer you any significant lateral resistance. So it is better that there are some systems continue to which you continue till the bottom. Mr. Magaj is saying passive pressure question is different question. Yeah, I got your I understood that it is a different question. My answer was that first of all it depends on the footing shape, and let's say it's an isolated footing, passive pressure is not acting on a large area, so you cannot really get any significant advantage. Let's say if it is a wall, and for this wall you had provided this footing, from inside there was an active pressure and from outside there was a passive pressure, then you can take advantage. But if it's an isolated footing column, passive pressure is acting over a very small area, so no real numerical advantage you will get. Mr. Vijay is asking, will you do a course on RCC detailing? In our basic course on RCC design detailing, we have already talked a lot on detailing aspects. So you might be interested to have a look at the basic course on RCC design detailing, where we have discussed a lot of things on detailing of reinforcements, how to present it to client in form of drawings. So all those things are already covered to a fair degree of, to in a fair manner in this course on RCC design detailing. So you can go to our website, go to the basic courses on Indian codes and have a look at this. Alt think S. He is asking, in design of flat slab, we need to check for stiffness of slab and column and alpha C mentioned in IS 456 table 17. What is this table 17? Let me have a look at table 17. Table 17 is what? Table 17. 15, 16, 17. Where is 17? Okay, minimum possible values of alpha C. This alpha C, what is it doing? Okay, yeah, this is correct. So this is giving you the, all right, got it. Yeah. So this alpha C is giving you the proportioning of the moments on a flat slab system if you are using the direct design approach. Correct. So, uh, yeah, you need to then take this alpha C value and do it if you are using the direct design approach, direct design method of flat slabs as per the IS code. See, if you are using a software like Safe or ETABS, then you do not need to do this direct design because then the software itself is doing it. But let's say if you are doing manual calculations, then you need to consider this alpha C. Mr. Magadi is asking what could be the R value for zone 3 for movement frame system and just want to detail as per 13920 but not design as per. No, there is no such option, no such offer that IS 13920 gives you. So you cannot pick and choose. Technically, as per the code, you cannot pick and choose that I will take the R of 3 and that means of OMRF and I will do the design detailing only as per 13920, not check for uh, the joint shear and beam column capacity ratio, and therefore I'll just take a lower R. That means I'm designing for higher earthquake forces on all those things. So this kind of an offer code does not give you. Okay. Yes. Then Mr. Chinmay Sarkar is asking, one consultant in Kolkata used transfer slab. They built 2 meter thick slab on 8th floor and then from there they built another 18-story residential. Very good. Yeah, so some elements they will take right till the ground and some elements they will stop on the transfer slab. So the elements, the shear walls or columns that are going right till the ground, they will help you in the in providing the lateral load resistance for the system. अभय जी इज आस्किंग, यदि 7 मीटर के ट्रांसफर यदि 7 मीटर के राफ्टर के टॉप फ्लैंज पर 1.5 मीटर सेंटर टू सेंटर पर्लिन लगी है और बॉटम फ्लैंज पर कोई टाई मेंबर नहीं है, तब राफ्टर का इफेक्टिव लेंथ फैक्टर्स क्या होने चाहिए? So in this case, generally the detailing goes like this, Abhayji, that if this is your rafter and purlin is attached like this on top, if you see the detailings, generally what they do is that wherever the purlin is on the raft top, they will add this element which is called as the flange bracing. Okay, so this flange bracing, what it does is that at the top chord, you are getting a tie from the purlin. Now for the bottom chord, because it was unsupported, so this flange bracing provides support to your bottom chord also. So whatever effective length factors you are giving for top chord, same you can give for bottom chord also because this flange bracing is getting connected. So you are not keeping your bottom flange unconnected. You are providing this flange bracing and having the same sort of lateral support that you are getting at the top flange. So at top flange you are getting the lateral support from purlin and at the bottom flange you are getting lateral supports by introducing this kind of a flange bracing. So this detail you will always see in the drawings. If you are referring to some drawings by PEB people, you will always see such kind of a detail. Okay, good. So anything else? So these were the questions that were asked. We have taken all the questions from the Google form and we have also taken all the questions from live comments. So any other question, please? Flange bracing. No other question? I'm just looking for a flange bracing picture. If I get it, I'll show it to you. Flange bracing. Flange bracing. In this Zamil Steel handbook that I have shared with you earlier, you will get some good images. So you might be interested in watching those. Yeah, any other question, please? Okay. So no other question. I'll just wait for a couple of minutes. If there's any other question, we'll take it up or we close this session. Yeah. So whenever you have queries, you can put it on this Google form. As I have told you, the Google form remains the same. Once every week when we meet, we take up your queries. So once every week we take your queries in the live session, but the questions throughout the week you can put it in the same Google form. Okay. I was just looking for a detail of flange bracing. I'm not able to get right now, but I hope you understood by the meaning of flange bracing. Yeah. Okay then. So I think no more questions. Oh, there are two more questions. Three more questions. Wait a minute. If there is requirement of both, Mr. Magai is asking if there is requirement of both one-way and two-way shear reinforcement. Which reinforcement is going to govern? And how do we sum up both the shear reinforcement? Or do we need to go with the governing case? What does this mean? Is there if requirement of both one-way and two-way shear reinforcement? See, generally this type of a thing does not happen because what you will see is that if you have a slab uh, directly resting on columns, it is going to be the two-way shear that governs. So if there is a column and there is a slab, and then you see this kind of a system, it is going to be the two-way shear that governs because the shear forms a closed periphery. Now you could say that this is one-way shear on this surface. Yeah, you could say that this is one-way shear on this surface, one-way shear on this surface, one-way shear on this surface, and so on. But actually speaking, it's a closed surface that you see. It's a two-way shear that is being formed. So I don't think this kind of a situation occurs uh, where both, let's say, one-way and two-way shear reinforcements are you are getting. Generally, it will be either you are getting one-way shear or two-way shear because of the connectivity. So if this column was connected with some beams, then you will see more of a shear, critical shear along these lines. It's more of a one-way shear that you are getting. So I won't say that these are two different things. It's just that if the shear, critical shear, is having a closed perimeter, then we are calling it as a two-way shear. If the critical shear plane is along a line, then we call it as a one-way shear. They are not two different things in my view. So depending on the system, if you are having a flat slab, then it's the two-way shear that is going to govern. If you have connectivities with rigid elements like beams, stiff elements like beams, then it is going to be the one-way shear that is going to govern. So I don't think you have to add up the reinforcements, or it will be either or situation. Okay. Ashwin Govind is asking how to design columns if the design moments in upper story is greater than lower story and PU load is more in lower story. No, how to design means you have to, when you do the columns, let's say this was your column, this is your one floor level, then this is your another floor level, then this is your another floor level. These are my floor levels. So this is floor level 1, This is floor level 2. This is floor level 3. Now, when you are designing this column, you take the axial force and moments at this point, axial force and moment at this point, accordingly find out the percentage whichever is higher. So let's say here you get 1.2% reinforcement. Then again for this column between floor 2 and 3, again you take the axial loads here, moments at this location, find out a percentage at column top, at column bottom again you do the same procedure again. Then whichever is critical you say that this is the percentage I am getting, whatever. So this is the percentage for this for the column between these two story levels. Then you decide what percentage you finally want to continue, whether you want to continue the 1.4% reinforcement throughout, or you want to provide different reinforcement percentages at different levels. It's your choice as a designer. But always, whenever we design columns, we will do it at every floor level. Okay. Then so then Mr. Raghu is asking a related question. If the top floor column reinforcement is more than the lower floors, how to provide the reinforcement? So then you have two choices. Either you have this reinforcement provided at the bottom level also. So that means you continue 1.4% from bottom to top, or else you provide a separate reinforcement over here and separate reinforcement over here. Then if you are going to change the reinforcements, either you may have to do lapping of the bars, or you can add reinforcements. uh, of course you will have to add reinforcements, then you will have to discontinue some bars, you may have to start it from this column itself, some bars, and then at this level you will have then more bars, at this level you will have lesser bars. Such type of detailing arrangements you will have to think of. Okay, very good. Mr. Raghu is asking, can we use a coupler to connect two different bar dia? No, because generally I have seen the couplers to be of a constant dia. So this coupler is a cylindrical thing of a constant dia. So now you cannot have a bar which is of higher dia and lower dia connected because they are threaded. So your bar is also threaded, and in the threads you fit in the coupler. So two bars of different dia cannot be connected to a same coupler. Okay. Mr. Ajinkya is asking, for flat slab, safe shows very less reinforcement compared to direct design method. No, I have not observed this. In fact, in our courses also we have done this, that uh, when we are taking a simple configuration, the moments that we are getting, analytical moments that we get using the manual calculations and what we get in safe are similar. So I don't agree with this point that you are making, that you are getting different analytical movements. So for a simple, you try with a simple case, maybe a 4 by 4 grid, try with a simple flat slab, do it using the direct design method and the safe analytical movements. What you are saying, what you are getting, they will be almost similar. See, when it comes to reinforcement calculation, there might be different things that you are doing. Maybe you are committing a mistake in choosing the reinforcement grade, or maybe you are committing some other mistake, that is possible, but moments will be same that you get, and I have checked it myself. Mr. Rishabh Thackeray is asking, is plumb concrete retaining wall more efficient than RCC retaining wall? No, it's not about efficiency. It's not about efficiency. It is about the way in which it's about the way in which it will act. So if you are making a wall out of plumb concrete, maybe you are trying to make a gravity type of retaining wall. So you are relying on the weight of this wall to counteract the lateral forces. Yeah. If you are making a cantilever retaining wall out of RCC, you are relying on this weight that you will be putting, and this weight will offer you this weight on this portion. This is called toe or heel. I always get confused. This portion on which you will put the fill which will help you to uh, I mean offer a counteracting movement. This is called as toe or heel. I think heel. Hello. Anyway, I always get confused with the names. I think it is called as the heel. So in the cantilever retaining wall, we are relying on a different concept, heel. Yeah. So in this heel, this load on this heel, this offers the counteracting moment against the lateral pressure. So this is a different concept that we are using. In plumb concrete retaining walls, we are relying on the gravity, just the weight of that retaining wall to offer you the counteracting moments. So it's not about which is better, which is worst. It is about the action in which we are resisting the overturning moments. So it's not about the efficiency. It's about your choice that you have as a designer. Mr. Magaj is saying one and two pile caps in safe shows unstable. No, no. See what happens in the this often people get. See what is happening is that you provide this kind of a slab, sorry, pile cap, and this is the pile. Now in safe, what you are doing is that you provide this pile cap, and then you are modeling it with a point. Okay, so generally what happens that in modeling we are making it a point over here, and then we make a shell element like this. Now this point you are assigning some spring stiffness. Okay, now that spring stiffness, generally you will only give lateral stiffness, sorry, you will only give vertical stiffness to that spring. Now what happens in case of this pile cap is that these points are all unbalanced, so to say. So any load or anything that you apply, this thing is free to rotate, sort of. Understood? Because there is no restraint that you are providing in the safe model to the pile cap. So therefore you will see very large deflections at these points in safe, and then we get confused that what is happening. So what you can do in such cases is it's okay to provide translational restraints to these four corners. It's okay to provide translational restraints to these four corners, and maybe you can also provide some subgrade modulus to this area element. Now that subgrade modulus may be corresponding to a 5, or let's say 5 to 6 or 50 to 60 kilonewton per meter square SBC. According to for that, corresponding to that, you may provide some spring constant. Okay, and just tie these 4 points for lateral restraints also, for translation restraints also, and then see that there is no area load that is getting applied on this. Otherwise, you will get problems. You understand what's happening? Because when there is only one pile cap, this portion of the pile cap is free to rotate, free to translate in safe. That's why you get these large deflections sometimes in the pile cap. So you can do such thing to just safeguard against it. Yeah, Mr. Magaj is also saying that the safe values and the direct design method values match. Yeah, they match. We have checked it. Uh, in You can do it for normal 4 by 4 grid maybe and try it out. Ashwin Govind is saying, can you explain about sunken slab and its purpose? Yeah, translational restraint means UX, UI, you just put a check mark on it. And as I told you, additionally, you can also put some subgrade modulus below the pile cap. So you are already providing spring stiffness to the pile point. I am saying you also provide some value of subgrade modulus to the pile cap, and also ensure that there is no direct load that is acting on the pile area. Otherwise, it will cause problems. So this is more of a software issue because of improper connectivity or supporting systems being provided. Ashwin Govind is asking, can you explain about sunken slab? So one of the purposes of sunken slab is, of course, to take your plumbing. So your plumbing lines, if you don't want to show them, so let's say this is your ground, this is your normal slab, and Suppose you had to have a western toilet seat installed. Now the pipelines for this, let's say, are like this. Okay. Now what to do in such a thing? So one way is to make it on a raised floor, but then it does not look good if you were to make it on a raised floor like this, isn't it? So then you will have to raise your slab. So architecturally it does not look good. So then what do we do? That instead of raising the slab, we might sunk the slab like this. So this is the main purpose of providing sunk slabs, where we mainly do it in toilet slabs, toilet sunks. Okay, so this is one of the main purpose of providing a sunk slab. Yeah, and there might be other reasons also, but primarily in residential spaces, uh, when we provide sunk slabs, this is the reason behind it. Good. So anything else? Mr. Magaji is asking when to go for crack width check for footing. When your footing is under, or when your footing is placed in a strata which has continuous presence of soil water, and if that presence of soil water is going to be harmful, let's say if you have high sulfate content or chloride content in the water, soil water, and your footing is always going to be in contact with that water, then you should try to check for the cracks. But generally in footing, the cracks will be on the bottom, and that bottom surface is generally uh, attached to PCC. Therefore, for footings, we usually don't go for crack width checks, because that bottom surface is not directly exposed to the soil, right? There's a PCC over there. So generally we don't check it. C for civil is asking eccentric footing is minimum depth for residential structure as per IS. No, there is no minimum depth criteria given in the IS code. You need to find out from your calculation what depth you are getting. Very good session we are having. There are lots of questions. So anything else? Okay, so Mr. Raghu is asking lapping two different bars. That is 32 mm at top floor and 25 mm at bottom floor. Is this lapping feasible? Yeah, of course, you can lap. Feasibility will come, I mean, for feasibility of lapping, you need to see in which zone you need to do this lapping. It is suggested to do the lapping at the column mid height. So the lapping zone you have to decide. But of course, lapping is done. In all structures, lapping is done. The zone you need to properly assess as per your knowledge of ductile design detailing. C for civil is saying in pile cap, the rebound hammer test is less than beam is more. What does this mean? In pile cap, the rebound hammer test result is less and beam is more. What is the question over here? See, there can be a lot of reasons why rebound hammer. There are a lot of reasons why rebound hammer is not a very good test. It is just a basic way of giving you some indication about the concrete. It's not a good test as such, uh, for diagnosis, I will say. So rebound hammer results should be seen with caution. Your rebound hammer results will vary if you are not holding the rebound hammer properly, in which direction you are doing the rebound hammer test, in vertical direction your rebound hammer test, or if you are holding your rebound hammer horizontally. All those things do affect the rebound hammer test results. Personally, I don't like the rebound hammer test a lot. It's not a good way of, it's not a good diagnostic test. Okay, it's just an indicative test. So you do some rebound hammer and then you move on to some other uh, test procedures. That is the way to do it. So don't rely on rebound hammer too much. Okay, because there are a lot of issues, lot of different possibilities with rebound hammer. Whether on beam you are having your plaster, on your pile cap maybe you're not having plaster. A lot of things there are different. Mr. Magaj is saying thank you for replying all the queries with great explanation. Learning a lot from you. Thank you. Mr. Civil C for Civil is saying why cantilever beam is spring reinforcement provided in slab. What does spring reinforcement mean? Question not understood. Okay then. So I think I'll stop for this session. We will meet again next week with more queries and more interaction. So throughout the week, if you have any queries, you know the Google form where you can put your queries. And as you know, once every week we meet and we take your questions. So this is the Google form. And yes, thanks, Mr. Raghu. So this is the Google form where you can put your queries throughout the week. And if you want to connect with us on WhatsApp, this is the link through which you can connect with us on WhatsApp. I'll just put it over here. So yeah, so this is the link to connect with us on WhatsApp. So this is all we have for this session. Now we will see you next weekend. So next weekend will be the 50th episode of this Ask AuxEn Anything series. So let's meet next weekend now. And that's all for this weekend. Have a good week ahead. See you next time. Bye bye. And thank you so much for joining.